All right. Hello, everybody. My name is Ben, and this is part 3, subsection A, in a video series I am doing, in which we implement a DSL for UI testing in Rust. So in the last video, we built a very basic scanner, and if you didn't see that, I recommend you go back and watch it. The concept of the scanner is that we take in basically just a string with our code, and we scan over it to produce a list of tokens. That is the sort of like a programming language's version of words. These entities that have some kind of semantic value to them. What we're going to do now is refactor that a bit, remove a sort of hacky thing that we did to get it working, and add documentation and things like that. I'm sort of glad we're splitting this into 2 separate videos. So if you want to stick around and watch refactoring and finishing up the scanner, awesome. If you feel like you have a good concept of how it works, and you want to move on to parsing, go on to video 4. But without further ado, here we go. Okay. You know what? Let's exit out of that. Okay, here we go. So I did go ahead and make a small change since the last time we looked at this, which is that in the prior video, in order to be able to just sort of split on whitespace for our source code, what we did was we went into all the string literals, that is like some text surrounded by quotation marks, and in those we replaced whitespace with a tilde, and then that way we could just split on whitespace, look at each part of that split, and then once we decided to once we were building tokens, we could replace the tilde with whitespace again. The problem with that, of course, is that sometimes people might want to type tilde. So I've made a sort of small change to get around that. So what I've done is I've changed the signature of this resolve token method. It previously returned a token. Now it returns an option token. And what we do is we basically go ahead and split on all the white space, including white space between quotation marks. And then when we try to resolve a token, if we get something that starts with a quotation mark, then we sort of go into string literal building mode, and we stop returning tokens for a while, and we start just patching together the rest of the string until we find the closing quotation mark, and then we go back to returning tokens. So as you'll get a sense for how that works as I'm refactoring. I didn't do it on camera because it was about 45 minutes of me thinking and Googling, and then 2 minutes of me typing code. So let's start up here. Okay, so we have our tokens. We have our token type enum. Let's give this some proper documentation. Represents, I can spell. All types of schnauzer UI tokens. And if that seems like a redundant comment to you, you're right, but these sorts of things actually, I think sometimes redundant comments make the documentation nice to read. We'll do like a cargo doc at the end and take a look at our documentation. Okay, so we have the locate command. Locate is a command for well, I guess we probably don't need to document each of these just yet. Because they are subject to change, and I don't think anybody's going to be interacting with them just yet. Let's go with what we got for now. And then, okay, so we have represents a schnauzer UI token, right? And then we have obviously the type of the token, and then we have the line the token was found on for error reporting, right? And then let's do scan it. We actually put something at the top of the module when we were talking, right? Yeah, let's do that. The purpose of the scanner is to transform a list of characters into a list of tokens. And let's just give a little example. Let's say let's tokens equal scanner new. And then we give it some source code. So let's do let's source equal locate username as type test at test.com, right? That's messing with my syntax highlighting. That's frustrating. Oh, it's because we'll do it. Test.com. Yeah. Okay, my syntax highlighting is super weird on this code example. Can I turn that off? No. Okay, that's overtly strange, I guess. Yeah, well, we'll go with that. We'll see how it turns out. Scanner new from the source code. We'll give it the source code. And then we'll call .scan. And that should return a vector of tokens. Right? And we'll say let's just give this a type so that people know what's going on. Okay. And then, honestly, if I just go ahead and cargo test now, it should give me an error. So for those, again, we want to stop every now and then and explain for people who are not Rust people. Documentation code that is part of your docs in Rust, like if you have sort of some example code in your doc comments, gets compiled as an integration test. I think it's great. I think it's something awesome about the Rust ecosystem. Basically, it encourages people to write documentation because documentation can serve as tests at the same time. And so as a result, you have a sort of Rust ecosystem where even fairly obscure packages, like, or fairly obscure crates, like maybe the one we're making right now, are usually well documented. So let's take a look. Yep, there we go. That's what I was looking for. Let's do, and instead of just scanner, let's do all, because we'll want tokens too. Now let's try the test. Expected struct. Oh, it takes a string. Okay. So we'll say to owned. And there we go. Right, so basically this example code compiles, therefore it's a passing doc test. So the idea is that if, and you can do asserts and things like that too, but the idea is that if we changed our code to the point that, you know, maybe we changed the name of the constructor from new to from source, right? Then this test would no longer compile, and we would get a failing test that says, hey, you need to update your documentation. The idea that out-of-date documentation is a failing test, I think, is the right idea. Okay. Oh yeah. Why did I put this on the impl block when I so clearly wanted it? There. Okay, cool. Now let's look at our fields. This is the source code. It's a string, right? This is basically a buffer for collecting tokens as we scan the source code. This represents the current line number. And we'll probably add some error reporting during this video. So this is the that buff string. That's what we talked about, the way that resolve token works. So let's go over that really quickly. So resolve token is a method, and it really doesn't need to be public, but we're sort of making right now I'm sort of leaving everything public, because eventually we're going to expose quite a bit of this so that people can build it into Rust projects, or really any sort of programming projects, as opposed to being limited to just sort of running this through our interpreter with our Selenium grid and whatnot. Right? There's no real reason this even has to run on Selenium. It could run on different technologies. But okay, so we have this resolve token method that takes a lexeme, which is the string representation of a token, right? What the token looks like. And tries to resolve it to a schnauzer UI token, right? We may end up changing the signature to return a result as well. It just depends on how we want to do error handling in the scanner. But we'll say for now, string literals are passed by the scan function in parts in pieces, are sometimes passed by the scan function in pieces due to splitting on white space. So the function returns none while it is in the process of rejoining those string literals. Right, so, and I hope that sort of makes it clear what's going on here. So this function, in the scan function, we can say produces a vector of tokens from the provided source code. And again, if you're wondering why this isn't one big function, mostly it's because having sort of attributes on the struct, you can think of them as like members of a class, it's sort of easier to type than in C. Sometimes you get these functions where you have 18 pointers to some state you're managing in your function. And maybe that's a criticism of our design, but I think we're doing okay. Produces a vector of tokens from the provided source code. And then, so if you look at what we do, we split the source code into lines. And actually, we can probably inline this. Right, and let's, yeah, that's still working. Okay. So basically, we want to process a line at a time. Right, there's never going to be a token on the next that's split between two lines. So we process a line at a time. Obviously, incrementing line here is increment current line source code, increment, we'll say tracking for the current line of the source code. This is sort of confusing. For line, this says line, this says line. Those are different things. Let's call this statement, because that's pretty much what it is, right? In our grammar, each line is a statement. So we're taking our script and we're splitting it into lines. So this is a line. This is a line, this is a line, but each of those is really a statement inside of our grammar. So we can call it that. And then we split by a single white space character. Notice that we're not splitting by, we're not calling a method like split white space anymore. Right? And that's because of this, right? If someone wants to type something into a field with a certain number of spaces in it, we need to keep track of how many spaces there were. So we can't simply split on white space without remembering how much space we actually had around. So we split on this white space character, and then we call resolve token on the item. And if resolve token says, hey, that's all the information I needed to get a token and gives us back one, then we add that token to the list of tokens. So, I mean, we can comment all the way down the line, but I think that's fairly straightforward. So let's look at, and then we add an end of file token. And then we return the tokens. The reason we're cloning the tokens is because we're not consuming the scanner. We're sort of keeping it around, so we have to clone the vector of tokens. If we don't find a good reason to keep the scanner around, we'll make that more efficient later. Okay. Yeah, so you can imagine how this works. So if we look at our script, the first thing it's going to split on is here, and it's going to pass the word locate to resolve token, and that's going to immediately say, okay, locate, that's a locate token, and that's going to immediately give that back. All the keywords are going to immediately come back. But then when we get out to this line right here, right? It's going to pass this in two parts. It's going to pass, well, really in a ton of parts, but let's look at it like this. It's going to pass this in two parts. It's going to pass this password 123 with the quotation mark in front, and then it's going to pass this JAL with a quotation mark on the back. And there might be something in the middle, right? There might be another word in here, like, you know, I'll just add some random characters. But what we want to do, and I'll make this 2 spaces, right? What we want to do is we want to preserve the structure of that string. So when it gets something that starts with quotes, it's going to switch modes. So we have this buffer for, you know what, we can type the rest of the word. We have this, let's actually call this the string literal buffer, right? And this is used to collect the pieces of a string literal that may have been split by white space, right? And then we have this in quotes field, which just keeps track of whether we are currently scanning between quotes. So if we come look here, yeah, so we have our commands, and what a command will do is it'll basically say, hey, I recognize that that's a command, and then it will build a token for us out of that. But then we have the beginning, or we have sort of three scenarios we need to worry about with string literals. Sometimes we might get past an entire string literal, right? So the text they gave us had no spaces in it. That would be like this, username. So we get past username with quotes around it. And so the way we're checking that is we're saying, do we get some reference to a string, right? Some answer where it starts with a quote and it ends with a quote, and we're not currently between quotes. So the idea here is like, the idea of including this is that you might get something like that, right? Or something like that. And we sort of need to figure out how we want to handle that because it's not being handled right now. But anywho, if we get an entire string literal, then what we want to do is we want to build a string token, right? So we're going to give back the token right away. We're calling self.token just to add context to add the line number. And then we construct this token type string, and we give it the word, but we strip the quotes from the front and the back. And we can probably make this more readable. Maybe let's have a util. Yeah, I don't know that we'll reuse this, but we'll say function strip quotes, and we'll have it return let's have it take in as a keyword. We'll call it input, right? And let's have it return a result string. And basically what we want to do is this. We want to take the input. We want to strip the preceding quote, right? If there's a quote in front, we want to strip it off. And then if there's a quote in back, we want to strip it off. And then rather than passing a reference around, we want to just upgrade this to a string. But rather than unwrapping, we want to do proper error handling here. So let's add util. Great. This enum takes, oh yeah, I got to say what kind of error we want to give it. Let's do that for now. And then rather than unwrapping, so strip prefix returns an option string. So let's do this. Let's do okay, or yeah, and then we can provide the error. And in this case, we're going to provide sort of tuple, and then let's throw it, and then we'll say okay, or empty tuple. And then let's throw it, and then let's say toOwned, and let's say okay. Yeah. There's probably a better way to write that. Okay, so basically we're taking the input, we're trying to strip off the quote, and if that doesn't give us back anything, then we're going to provide this error type, which in our case we're just giving it an empty tuple. We'll build custom errors for everything later, and then we're going to try to strip the suffix, which, you know, the closing quote, and if that doesn't give us back anything, then we're going to error again, and then we're going to upgrade it from this, you know, reference to a string to its own big boy string, and then we'll say, okay, we got it, and we'll give that back. So now in scanner, we can say, sorry, everything looks different because I ran cargo format. Instead of all this, we can say strip quotes, word, and then we'll say we're going to add error handling soon. For now, we're going to expect error trying strip quotes from and then let's print the word. Right? So we know if we're trying to strip quotes in the wrong place. And really that's, I think it's fair to have an expect there. That's something that if we get to the point where we're trying to strip quotes from something that's not a string literal, that's our fault, not the user's fault, I think. Off the top of my head, I can't think how we would end up with that being a user's fault. Actually, so we check, right? In order to go down this branch, we check that this word starts and ends with quotes. So we can unwrap, and that's safe. Yeah. And then if you ever unwrap in Rust, you want to explain yourself. Safe because we checked the string began and ended with quotes and the match guard. Right, the match guard being this thing, this little if statement. Okay. So if we get an entire string, strip the quotes, and construct the token. Right? I hope that is readable to someone who comes across it. Okay, let's look at this one. This is if we start with quotes. So if we start with a quotation mark. The only thing here is we've got the first part of a string, but there's ostensibly more to come. So let's say if part of a string switch to string literal building mode, basically, right? So could really say the first thing we need to do is this. Right, we are now inside quotes. And then we take the buffer, we take the string literal buffer, and we push the string without the preceding quotes, without the preceding quotation mark, to the buffer. So let's say let's string literal without preceding quote. Let's say let's without prefix quote equal this. And then we can sort of say unwrap is safe because we checked the string began with a quote in the match guard. And then let's add without prefix quote. Temporary value dropped. Oh, okay. Let's just say to owned again. And then, yeah, are you mad at me? I'm sorry. It's more readable. Strip the front quotes. Add beginning of the literal to the buffer. And then here's the interesting thing. We also add the single white space character. This is important for two reasons. One, it's important that we do it here, I think, for a couple of reasons. Rather than trying to split on white space, the idea is that if we have a bunch of spaces, right? So if we have like this, then that's why we split on a single white space. So we split on a single white space, and then we should just add back the single white space. So that could happen here, in which, like, if we just ended up getting a quotation mark, then we want to add back that single white space. It could also happen in the middle, and it could also happen at the, well, I guess it's not going to happen at the end, right? Because we're going to be at the end of a new line. I don't know. We'll keep it how it is for now, and if we discover an error, we'll deal with it. Okay. Yeah. So we add, or we'll say, add back the white space to the string. And then return none, right? Because we're not, now that we're in string literal building mode, we don't have a full token to return yet, so we're just going to give back none. Okay. If we get one, let's do this part next. So this says if we get the last part of the string literal, right? If we get the part of the string literal that ends in a quotation mark. So we'll handle that in a second, but I kind of want to talk about the middle first. So this is if we get some word, it doesn't have quotes at the beginning or end, but we are in between quotes right now. That is this person, right? They're not at the front of the string, they're not at the back of the string, but they are in between the quotes of a string literal. So get part the middle of the string literal. Well, in that case, all we want to do is we want to add the part to the string literal buffer, right? And then we want to add the white space back. So in that case, we're adding this, and then we're adding the white space character we split on. And then for each of these following white space characters, when we split on them, we'll have a sort of empty string. And so we'll push back an empty string, which won't have any effect, and then we'll push back the white space character that we originally split on. So we should add back the same amount of white space characters that we took away. And then we get to the end here, which is if we get the last part of the string literal. So let's do self dot in quotes equals false first, right? We're exiting the quotes. Then we I wonder if I even want to have that util function, because I can just sort of unwrap each time because it is safe. So this util function we just made, let's just bring it back, right? Let's do yeah. Well, let's go all the way back to where it says word, right? It was a good thought, but I mean, who really wants to have a util module for one method? So let's do, and who wants to deal with who wants to return results just to unwrap on them later, right? Let's see. So rather than strip quotes unwrap, let's just do, yeah, we're stripping the front quote and the back quote. So we'll say strip front and back quotes, and then we justify our unwrap. Okay, let's pretty much have the same thing going on here. Let's without end quote roll that to owned, and then we'll do without end quote. So we'll say strip the end quote, so quote and match guard. And then add the end of the literal to the string literal buffer. I know this seems like a lot of commenting for the code, but I think it's not doing any harm right now, and I wanted to sort of go through it with you so that even though I didn't end up writing this code on camera, you can see how this works, or how we've chosen to go about it. And then what we're going to do at the end here is we've sort of finished collecting our string literal, right? We've reached the end with the closing quote. So what we want to do now is we want to return a string literal token. So we're going to save the string literal buffer as the sort of resulting string literal token, and then we're gonna clear the buffer so that it's empty for the next people. So we can say return. We can say clear the buffer and return the string literal. Right? We can probably do this like, I think there's a method called clear on string. Is that what you do? Removing all contents. Yeah, cool. Yeah, that way we're not allocating another string. Not that would slow us down significantly compared to the web automation we're going to be doing with this. But okay. Yeah, I think that's fairly straightforward. This method produces a token with the given scanning context, right? So right now the only context is we keep track of the line number, and we use that for error reporting. Okay, now that we've got that sort of sorted, so I think that's pretty readable. We don't really have to comment this constructor because everybody knows it's sort of a convention in Rust that this is the constructor. So you should be able to give it some source code, and it'll produce a scanner for you. Okay, the other thing is that I don't think we have everything in place. So we have locate, type, click, report, refresh, try again, screenshot, had error, if, then, and. We talked about, let me pull up whiteboard. We talked about doing a read command, right? So if we look at our grammar, right, so yeah, we have locate, report, click, type, refresh, try again, screenshot. We talked about doing a read command, that is reading the contents of some element into a variable for use later, and we have this concept of variables, so I think we ought to use them. So let's do a third command. I think the way I want it to work is you would say something like locate and then give it a locator, and then read to. Yeah, we could say read to, and we'll separate it with a dash, and then you give it a variable name, and that will create a global variable for you. So let's do one final command. Read to, and that's going to return some self.token type. We'll say read to, or I guess we could say, yeah, I think that's the best. I think TagUI had it right. If we look at our tokens, we just need to add a command. Read to, yeah, that should do the trick. So what are you mad about? Oh, I got rid of that. Okay. And then you're mad about the mod util. Yeah, and then we're good to go. So let's add that statement. Let's do some spacing in front. I want to make sure this string parsing works exactly. I want to make sure this string literal parsing works exactly right. And then let's do locates table, whatever, it doesn't matter, and read to, and then we'll give it a variable called my variable, right? And then let's get rid of that. Let's see what this all parses out as. Oh. 123.26. Okay, so here I am asserting that this unwrap is safe, and it's not. So how did we enter this? This is starts with and ends with, right? A none value. Yeah, 123. This is in the starts with and ends with part. So I guess being called on username. Or dot strip prefix dot unwrap dot. Let's print the word. Okay, so this is all inside of some. Maybe let's do a block so we can print what's going on here. Right, and let's say let's print the word. Username, test@test.com, password, and then this. So when we get to this opening quotation, so we're splitting on white space, right? So we split here and then we split here, and we get an opening quotation mark, and we pass that in, and you can't split. Okay. So that's if you start with some space, then you're running into trouble. Well, we could do a special, we could do a sort of check for a single quotation mark. Yeah, let's just do that. If word equals some okay, so here's the problem. That's the front of a string, right? That's the beginning of a string, but it's going into the whole string method, because it does if it's just a quotation mark, it does technically begin and end with a question mark. So let's add and word.len has to be greater than 1. Let's see if that fixes our problem. Yeah. Okay, so here's what we end up with, right? For this script, We have a token locate, a token that's a string literal with the value username, an and token, a type token, a string literal with the value test@test.com, and then we have locate, string literal password, and type, and then we have the string literal with all the spaces in the right spot. Yeah, looking good. Okay. And then we have locate, string table, and then we have the read to command, and then we correctly decide that my variable is a variable because it's not surrounded by quotes, but it's also not a command, and then we add an end of file. I think that's probably good enough now to get started on our parser. So yeah, 56 minutes. Okay. See you in the next one where we'll actually get started on the parser.